All right, today I'm going to actually introduce dividing fractions, which is our 6th grade standard. And I just want to start really quickly with a picture version so that you can kind of see it a little bit more. What are we asking when we're dividing? Well, 3/4 divided by 2/8 is a problem that is asking us how many groups of 2/8 can we fit into 3/4. So if you look, we made 2 fraction bars here, 2 bars. This one had 4 pieces. 3 of them were circled because 3 of them represent the 3/4 that are in our first fraction. In the second, we've broken this particular bar up into 8 sections, and we've shaded what 2/4 looks like, or 2/8, sorry, looks like. And we want to know how many of these 2/8 can go into the 3/4 we started with. So if you take a look at the shape here, you should recognize that this 2/8 is equivalent to 1 of the 3/4. So there'll be one group right here, plus a second group and a third. This piece can fit into this bar 3 times. So the final answer is 3. That's the picture representation of what dividing fractions looks like. I had 3/4. I wanted to divide it by 2/8. So I wanted to see how many groups of 2/8 would fit into these 3/4. And if you look, it fits in once, twice, 3 times. And that's where that 3 comes from. We'll do one more sample here and then we'll move on. So here again, I'm starting with 2/3. Okay, 2/3. 2 out of the 3 are shaded. And I want to divide it by 2/6. I want to know how many 2/6 can fit in there. So I had a bar of 6 and I broke it into, or I took 2 of those pieces. Well, if you notice, this right here is 2/6. And here's a second group. So the answer here is 2. Okay. Now, if this doesn't make sense to you, we're also going to show you another way to divide, but I wanted you to get a picture representation so you could kind of see what is it asking. The question is, how many groups of 2/8 go in 3/4? Oops. And how many groups of 2/6 go into 2/3? Now, as we turn over to the next side, I want to do a quick review of what a reciprocal is. So a reciprocal is one of 2 numbers whose product is 1. It is the result of flipping a fraction. So if you take 3/4, its reciprocal is 4/3. Okay? And if you were to multiply 3/4 times 4/3, we could simplify across here. So 3 and 3 share a factor of 3, and 4 and 4 share a factor of 4. When I multiply, I get 1. Okay? A reciprocal is a flipped over version of an original fraction. Now, if we do it over here, I don't have a fraction yet, but I can make 2 into a fraction by putting it over 1. And then its reciprocal will be 2 over 1. Will be 1 over 2 as I flip it over. In the case of a mixed number, before I can actually flip it over, I actually have to turn it into an improper fraction. And remember, 5 times 4 was 20, plus the extra piece I have, that's 21, and we still need 5 to make a whole. So our fraction is equivalent to 21/5. Well, that reciprocal, when we flip it over, is 5 over 21. So let me show you a couple examples of this. The reciprocal of 2/3, when we flip it over, is 3/2. The reciprocal of 13/3 is of 3/13 is 13/3. The reciprocal of 9/10 is 10 over 9. It's just a flipped over version of the original fraction. And again, remember, when you're doing a mixed number, we first have to turn it into an improper fraction. So 4 times 8 is 32, plus 3 is 35. We still need 8 pieces to make a whole, and when I flip it over, the reciprocal will be 8/35. And again, for a whole number, first we have to turn it into a fraction by placing it over 1, and then we can flip it over. And that's how you find a reciprocal. Now, that's going to be very important because the algorithm for dividing fractions is going to require you to find a reciprocal. And let's take a look at that. All right, most of you guys in elementary school learned KCF, keep, change, flip. Totally great. It is a fantastic mnemonic device for helping you remember the steps to the algorithm, but I do want you to understand what those pieces mean. So let's take a look. If I'm dividing 4/5 divided by 2/3, we're going to keep the first fraction in place. we're going to change from division into multiplication, and then we're going to flip the second fraction and make it its reciprocal. Keep in mind, if you tell me it's a flipped fraction, I'm going to ask you, what do we call those flipped fractions? We call them reciprocals. So the flip helps us remember what to do, but you also have to remember the vocabulary. So if I'm telling you you need to multiply by a reciprocal, you need to do that. So the actual algorithm for dividing fractions is to multiply by the reciprocal. We use KCF to remember that. So we keep the first one, we multiply, change to multiplication, and we flip to the reciprocal of the second one. So let's take a look at doing a couple of those problems. All right, in question number 1, we're going to keep the first fraction. We are going to change from division into multiplication, and we are going to flip this fraction over to make it its reciprocal. Then we're going to look top to bottom. Do we share any common factors? In this particular case, we do not, so we multiply. 5 times 3 is 15, and 8 times 2 is 16, and that's our final answer. Okay. Second problem, we keep the first fraction, we change to multiplication, and we flip the second fraction over, making it its reciprocal. And then we look, do we have any common factors between any factor in the top and any factor in the bottom? And we do. 2 and 10 share a factor of 2. Divide by 2, divide by 2. Now I have no other common factors top to bottom, so I simply multiply. 3 times 1 is 3. 5 times 1 is 5. And that's our answer. Okay. In the third problem, we're going to start with keep, change to multiplication, and flip the 1/4 to 4 over 1, making it its reciprocal. Again, we look for common factors, and here if you notice, 4 and 10 share a factor of 2. When I divide by 2, I get 2. When I divide by 2, I get 5. There are no other common factors top to bottom, so I'm going to multiply across. 9 times 2 is 18, and 5 times 1 is 5. Now, I told you in the previous video that 18/5 is an acceptable answer. It is a simplified fraction. But you do need to recognize that 18/5, 5 goes into 18 3 times with 3 pieces left over. So these are equivalent, and you need to recognize both of them. Don't just assume one is sufficient. I'm okay with either answer as a final answer, but you need to recognize that either one of them is the same. All right, let's take a look at number 4. So we start with 3/8, we keep it. We change to multiplication, but this 9 here isn't a fraction yet, so we're going to set it over 1, and now I can flip it over and make it its reciprocal, like that. So then we look for common factors. 3 and 9 share a factor of 3. So I'm going to divide by 3 on top and get a 1, and on the bottom and get a 3. There are no other common factors, so we simply multiply across. Okay. Let's take a look at question number 5. We are going to keep the first problem, or the first fraction. We will change to multiplication, and we will take the reciprocal of the second problem. We will flip it over. Now, there are common factors here that are shared. 5 and 10 share a factor of 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. And I really, really, really want you to get in the habit of simplify before you multiply. Because if you do, the numbers at the end are already simplified and they're far easier to work with. If we don't, we blow these numbers up when we multiply, only to have to divide back when we simplify. So if you do this, 2 times 6 is 12, and 1 times 11 is 11, and that is a perfectly acceptable answer. But if you divide here, 11 goes into 12 one time with 1 piece left over. So that's also an acceptable answer. And again, you need to be able to recognize both. In question number 6, 5/9 times 9/13. So we kept, we changed to multiplication, and we flipped over, making it its reciprocal. 9 and 9 share a factor of 9. And so when we're done, it's 5/13. Okay. We'll do a couple more problems just to make sure we've got it. So question number 7, first we have to change it into an improper fraction. 4 times 1 is 4, plus 3 is 7. That's 7/4. And we're going to keep this a division problem for a second because a lot of times kids will try to do everything in one step and we mess something up along the way. So all I did, this first step, all I did was change this mixed number into an improper fraction. Haven't changed anything. I haven't flipped anything. Now we will use our algorithm. So we're going to keep the first fraction. We're going to change to multiplication. And we're going to flip the other one over, making it its reciprocal. And now you'll see that the 7's divide out. And the 8 and the 4 share a factor of 4, leaving me with 2 over 1, which is equal to 2. All right, here we can make 3 into a fraction by putting 3 over 1. And notice I'm going to keep this division because I'm not using the algorithm yet. I'm just setting my fractions up to be able to use the algorithm. 8 times 1 is 8, plus 1 is 9. I still need 8 to make a whole. Now, I'm going to keep the first one, change to multiplication, and flip the second one over, making it its reciprocal. 3 and 9 share a factor of 3. No other common factors are shared, so I get 8/3, which is an acceptable answer, but that is also equivalent to 3 goes into 8 2 times with 2 left over. Both of those answers should be recognizable to you. All right, and the last problem in our examples here, we're going to set these guys up as improper fractions. So 3 times 3 is 9, plus 2 is 11. Notice I'm keeping it division. We're just working on one thing at a time here. 2 times 3 is 6, plus 2 is 8. Okay, now we use the algorithm. So we go 11/3 is we keep, we change, we flip over. We can recognize that 3 and 3 share a factor of 3. And that's it. So we will end up with 11/8. And I hope you recognize that this is improper. Totally fine answer, but we also need to understand that 8 goes into 11 once with 3 left over, and that both of those are equivalent statements. All right, that's pretty much the down and dirty for dividing fractions. I hope this helps, and I'll see you in class.